Okay, so in this lecture we will be discussing about continuity of a curve. Okay, continuity of a curve. Now what do we mean by continuity of a curve? Okay, so suppose we have two curves. One is your general sine curve. One is your general sine curve. This is your what? This is your y is equals to sine x, and this is some other curve, y is equals to fx. This curve is say like this, okay. This is some curve y equal to fx, and this is y equal to sine x. Okay, now let this point be x equal to a, and let here this point be same x equal to a. Okay, now let's see one thing. Now what is that? See, in this particular curve, imagine you are drawing this curve. When you reach x equal to a, you can still continue drawing the curve without lifting up your pen, right? Imagine you are drawing this curve, and when you reach, suppose you have started from here, and when you reach x equal to a, you can still continue drawing the curve without lifting your pen. Can you do it here? You cannot. You have started from here, you reach x equal to a, then you have to lift your pen and bring it here, and then again start drawing the curve. That means ki here is some discontinuity. Here is some discontinuity. Getting my point? Here is some discontinuity. These curves, which generally cannot be drawn without lifting your pen, the curves which cannot be drawn without lifting your pen are known as discontinuous curve, like this. And these curves which can be drawn which can be drawn without lifting your pen, these curves cannot be drawn without lifting your pen. These curves can be drawn without lifting your pen. These curves are known as the continuous curves. Now continuity is a condition which we have to know how to find the continuity of a curve at a point. Now how to do so? See, at this particular thing, अगर मैं लिमिट x टेंड्स टू a fx कैलकुलेट करना चाहूं, तो हमें क्या करना पड़ेगा? पहले फर्स्ट वी नीड टू चेक कि वेदर द लिमिट एग्जिस्ट्स और नॉट. एग्जिस्टेंस ऑफ लिमिट की कंडीशन क्या है? एग्जिस्टेंस ऑफ लिमिट की कंडीशन क्या है कि लिमिट x टेंड्स टू a माइनस इक्वल टू लिमिट x टेंड्स टू a प्लस. मतलब फर्स्ट वी हैव टू ट्रैवल फ्रॉम हियर, देन वी हैव टू ट्रैवल फ्रॉम हियर. व्हेन वी ट्रैवल फ्रॉम हियर, fx approaches this point. When we travel from here, fx approaches this point, and when we travel from the right, fx approaches this point. Now suppose this is a dash and this is b dash, and a dash is not equal to b dash. That means ki limit x tends to a minus is not fx is not equal to limit x tends to a प्लस fx. That means कि यहाँ पे लिमिट एग्जिस्ट ही नहीं हो रहा है, पर यहाँ पे x इक्वल टू ए पे लिमिट एग्जिस्ट होगा. तुम राइट से जाओ तब भी यही पॉइंट, तुम लेफ्ट से जाओ तब भी यही पॉइंट. लिमिट फ्रॉम बोथ साइड्स, तुम लेफ्ट से जाओ तो भी ये पॉइंट, तुम राइट से जाओ, तुम लेफ्ट से जाओ तो भी ये पॉइंट, तुम राइट से जाओ वो भी तो भी ये पॉइंट, राइट. तो दैट मीन्स कि यहाँ पे लेफ्ट हैंड लिमिट और राइट हैंड लिमिट आर इक्वल. So from here we get a very important conclusion कि for a curve to be continuous at a point, for a curve to be continuous at x equal to a, limit x tends to a fx must exist. Now is this the sufficient condition for the curve to be continuous at x equal to a? No. उसका भी एक एग्जांपल मैं दिखा देता हूं. देखो कि इसको सपोज कैसे कर सकते हैं. सपोज यू हैव अ कर्व लाइक दिस. Suppose you have a curve like this, say like this. Now these two curves are very close, very close, with a little gap in between them. And where is the gap? This gap is at x equal to a. Okay, this gap is at x equal to a. Very minute gap. And what is this? This point is fa. अच्छा, इसको मैं थोड़ा बड़ा करके दिखा देता हूँ. The curve is like this. ठीक है. This point is fa. I mean कि this here x equal to a. ठीक है. So here is a very minute gap. Now suppose we say कि when x approaches from left, it reaches this point. When x approaches from the right, it reaches this point. Now the gap is so minimum. In between them. That when x approaches from the left and when x approaches from the right, they both tend to a single point. Right? When x approaches from the left and when x approaches from the right, they both tend to a single point. Okay, this is the point. Now what is this point? This point is say some m. Let me make it a pretty clear. I have made a slight mistake here. Let this point be m, because this point is basically fa. They both will tend to fa because this curve is y is equals to fx. Okay? So they both tend to fa when x approaches a from left and from right. But f of a, the actual term is not defined here. There is a slight gap, because we have told that when x is equal to a, then fa is equal to m. We have made a slight glitch here. If a must be this, right? If we go along the curve, if a must be this value, right? If we go along the curve. But what we have done is we have left a slight gap. In between the two curves. Why? Because we have defined fa equal to m, which is not along the curve. That means कि देखो यहाँ पे इस कर्व के बिटवीन जो एक गैप बन गया, दिस गैप मेड दिस पर्टिकुलर ग्राफ डिसकंटिन्यूअस, क्योंकि हमें यहाँ पे पेन लिफ्ट करना पड़ रहा है. दैट मीन्स कि देखो यहाँ पे लिमिट तुम्हारा लिमिट x टेंड्स टू a fx exists, लिमिट x टेंड्स टू a fx exists, but still the curve is discontinuous. What is the reason behind that? The reason ये है कि लिमिट x tends to a fx is not equal to f of a. ठीक है? Limit x tends to a fx is not equal to f of a. So basically this is the actual condition which is required for a graph to be continuous at a certain point. ठीक है? तो continuous होने के लिए क्या जरूरत है? For continuity at x equal to a, limit x tends to a minus fx equal to limit x tends to a plus fx is equal to f of a. So this is the condition required for continuity. Got my point, guys? For the next lecture we will be studying some specific conditions of limit, and then we will be moving on to differentiability. Okay guys?